section 4.1 is an introduction to factoring, and this is basically what we're going to be doing throughout the rest of the chapter is factoring polynomials. Okay, notice my definition. It says factoring a polynomial means writing a polynomial as the product of other polynomials. So you're going to take, a binomial, trinomial, or any polynomial, and you're going to break it down into factors that will multiply back to equal the original polynomial. Okay, as we look at more examples, hopefully this definition will become more clear to you. Step one of any factoring problem, that means from this first section to the last section of chapter 4, the first step will always be to look for what we call a greatest common factor. Okay, if we're talking about numbers, let's say I have the number 12 and 16. If I wanted the greatest common factor of those two numbers, it would just be the highest number that would divide into both of those numbers. Okay, well 2 will go into both of them, but is there something higher? Okay, the greatest common factor, which I abbreviate as GCF, would be 4, because that's the highest number that will divide into both of these numbers. So when we're looking at monomials, just variable terms, let's say if I had 9x and 12. If I were comparing those two terms, I would say, well, they both have, 9 and 12. What do they have in common? What's the highest number that will divide into both? And that would be 3. And then I'd also need to see if they have any variable terms in common. Well, because the 9 has an x but the 12 doesn't, I would not include the x in the GCF. I would say that the GCF is just 3. If we had something like 15x and 20x, if I wanted to compare those two terms, what's the highest number that would go into 15 and 20? Well, that would be 5. And because they both contain an x, then I would include x in my greatest common factor. Okay, so let's look at some examples of how these are going to be set up. Okay, just the first part says find the GCF of 4x squared y and 18x squared y to the 6th. So again, you're going to look at the coefficients 4 and 18. What is the highest number that will go into both of those? Okay, that would be 2. Then I look at my variables. They both have x to the second power, so that's going to be included in my GCF. They both have y, but now I have to look at the exponents on the y's. Okay, they both have at least y to what power? Okay, they both have at least y to the first power, or just y. So always, what I tell students is look at the exponents. Whatever the smaller exponent is on your variable, that's what's going to go in your GCF. Because we want to know what do they have in common. What do they both have at least? Is kind of the terminology that I would use there. Okay, as far as what we're going to be using this for, the problems will say factor out the GCF. Okay, we're not just identifying what the GCF is, but we're actually going to factor it out of this polynomial. So my first problem says 7x plus 14. I would look at 7x and 14 and say, what is their greatest common factor? Okay, well 7 will go into both of them. They do not both have an x, so my GCF is just 7. To factor it out means I want to know what polynomial would I have left if I divided out this 7, it's kind of like division, okay? But however many terms I have in my problem is how many I should have in parentheses. So if I have 2 terms, this is a binomial, I should have 2 terms in the parentheses. So when I divide 7 into 7x, what is going to be left over? Just the x. 7 into 14 would give me a positive 2. So go back to our definition of factoring. It means rewriting a polynomial as the product of other polynomials. Well, I've just rewritten 7x plus 14 as 7 times x plus 2. These two are equivalent because I could distribute back the 7. 7 times x would give me 7x. 7 times 2 would give me plus 14. And my answer should always equal back to the original polynomial that I started out with. Okay, in that problem, my GCF was just a number. Let's look at B. 7x minus 3x squared. Well, what will go into 7 and 3? Nothing other than 1. So then we have to look at the variables. What do they have in common? Well, at least x. They both have x to the first power. So that's going to leave me with x into 7x would leave me with 7. X into negative 3x squared will leave me negative 3x. Notice the 7 and the 3 did not change. I've just taken out 1x from this binomial. And I still have a binomial in the parentheses. If we distributed this x back, it would equal back to what we started with.